Geoscientists reconstruct 6.5 million years of sea level stands. The pressing concern posed by rising sea levels has created a critical need for scientists to precisely predict how quickly the oceans will rise in coming centuries. To gain insight into future ice sheet stability and sea level rise, new research from an international team led by University of South Florida geoscientists is drawing on evidence from past interglacial periods when Earth's climate was warmer than today. Using deposits in the caves of the Mediterranean island of Majorca, known as phreatic overgrowths on speleothems, to reconstruct past sea level stands, the team was able to determine that the vertical extent of these unique deposits corresponds with the amplitude of the fluctuating water table, said author USF Geosciences Professor Bogdan Onak. That determination now is providing scientists with a way to precisely measure past sea levels. Working with colleagues at the University of New Mexico, University of Balearic Islands and Columbia University, the researchers' findings were published in scientific reports. In their project, the geosciences team documented the position and timing of sea level during key time intervals over the past 6.5 million years for which global mean sea level estimates have been highly uncertain. Their results contribute to the understanding of past warm periods to gain insight into the magnitude and frequency of sea level rise, which is critical for scientists' ability to forecast and make recommendations on adapting to future global warming. The team expanded upon their research previously published in Nature by investigating samples between 800,000 and 6.5 million years old. Using deposits from several of the Mallorcan caves and applying numerical and statistical models to estimate the corrections for glacial isostatic adjustment and long-term uplift, they translated the local sea level estimates into global mean sea level (GMSL). Their results show that during key time events, such as Pliocene-Pleistocene transition, when the Earth underwent a major transition from the warm climates of the Pliocene to the Pleistocene ice ages, the GMSL stood at 6.4 meters. During the beginning and the end of the mid-Pleistocene transition, the sea level was at -1.1 meter and 5 meters respectively. Overall, our results support that sea level dropped significantly after the Pliocene, said USF doctoral Alamona Dumitru, the study's lead author who is now a postdoc at Columbia University's Lamont Doherty Earth Observatory. The authors also show that local sea level before and at the onset of the Messinian salinity crisis, a major geological event during which the Mediterranean Sea became partly to nearly dry of water, was at approximately 33 meters above present level. These estimates may offer starting points for assessing whether sea level drawdown in the western Mediterranean happened gradually or rapidly, the researchers said. Our estimates are important snapshots of sea level still stands, but additional sea level index points will be useful to yield more context for our results, the team wrote in their journal article. By providing direct estimates of sea level using POS as robust proxies, this work advances our understanding of sea level position during several past warm periods. These results therefore contribute to efforts of studying past warm periods to gain insight into the magnitude and frequency of sea level rise. Team deciphers sea level rise from last time Earth's CO2 was as high as today. Scientists have discovered evidence in a coastal cave off Spain showing that more than 3 million years ago, when temperatures were roughly equivalent to those projected for the end of this century, sea levels were as much as 16 meters higher than they are now. While levels are not expected to rise that fast by 2100, the findings have significant implications for predicting the pace of near-term and future sea levels amid a warming climate, say the researchers. The scientists, from the University of South Florida, University of New Mexico, Universitat de les Illes Balears and Columbia University's Lamont Doherty Earth Observatory, published their findings in today's edition of the journal Nature. The analysis of deposits from Arctic Cave on the island of Majorca in the western Mediterranean serves as a target for future studies of ice sheet stability, ice sheet model calibrations and projections of future sea level rise, they said. We can use knowledge gained from past warm periods to tune ice sheet models that are then used to predict future ice sheet response to current global warming, said team leader Bogdan Onak of the University of South Florida. Sea levels rise in part as a result of melting glaciers and ice sheets, including those that cover Greenland and Antarctica. Ice around the world is wasting and already raising sea levels, but scientists have struggled to predict how things will play out in coming years. Reconstructions of changes in ice sheets and sea levels during past periods when climate was naturally warmer than today can help address the issue, said University of South Florida PhD student Ona Dumitru, the lead author. The project focused on cave deposits known as phreatic overgrowths on speleothems. The deposits form in coastal caves at the interface between brackish water and cave air each time the ancient caves are flooded by rising sea levels. In Arta Cave, which lies within 100 meters of the coast, the water table is, and was, coincident with sea levels, say the scientists. The scientists studied 6 geologic formations at elevations of 22.5 to 32 meters above present sea level. Careful sampling and laboratory analyses of 70 samples resulted in ages ranging from 4.4 million to 3.3 million years old, indicating that the cave deposits formed during the Pliocene epoch. Sea level changes at Arta Cave could be caused by the melting or growth of ice sheets, or by uplift or subsidence of land itself, said Jacqueline Osterman, an assistant professor at Lamont Doherty Earth Observatory and member of the research team. Osterman used numerical and statistical models to analyze how much uplift or subsidence might have happened on Majorca since the Pliocene, and then subtracted this from the elevation of the formations. One interval of particular interest during the Pliocene is called the Mid-Piacenzian Warm Period, which lasted from 3.264 to 3.025 million years ago. At this time, temperatures were 2 to 3 degrees Celsius higher than before humans began altering the atmosphere, a benchmark widely expected to be reached by 2100, unless emissions of the greenhouse gas carbon dioxide are sharply curtailed. This interval also marks the last time atmospheric carbon dioxide was as high as it is today. The study found that during this period, global mean sea level was as high as 16.2 meters, with an uncertainty range of 5.6 to 19.2 meters, above present. The scientists concluded that this means that even if atmospheric CO2 stabilizes around current levels, the global mean sea level will still likely rise at least that high, if not higher. In fact, it is likely to rise higher, because of the increase in the volume of the oceans due to rising temperature, they said. The authors note that a rise of this magnitude would take hundreds to thousands of years, due to the time it takes for the climate system to react to such high levels of CO2. Considering the present-day melt patterns, this extent of sea level rise would most likely be caused by a collapse of both Greenland and the West Antarctic ice sheets, they say. Previous studies of the Mid-Piacenzian Warm Period have produced widely varying estimates, ranging from 5 to 40 meters. The authors also estimated that sea level was 23.5 meters higher than present about 4 million years ago, during a time known as the Pliocene climatic optimum, when global mean temperatures were up to 4 degrees Celsius higher than pre-industrial levels. The research team also included Victor Polyak and Yemaine Asmaram of the University of New Mexico at Albuquerque, and Joan Fornos, Joaquin Guinness, and Angel Guinness of the Universitat de les Illes Balears in Mallorca. The research was funded by the U.S. National Science Foundation and the Spanish State Research Agency. Support for Osterman was provided by the Vedelson Foundation. Reconstructing 6.5 million years of Western Mediterranean sea levels. Researchers have reconstructed past sea levels in the Western Mediterranean in new detail by sampling coastal cave formations. With a critical need to predict how quickly sea levels will rise in the coming centuries, scientists are drawing on evidence from past periods when the Earth's climate was as warm, or warmer, than today. In a new study, an international team of scientists has used cave deposits from the Mediterranean island of Majorca, off Spain, to reconstruct past sea levels. The vertical extent of these deposits, known as phreatic overgrowths, corresponds with the fluctuating water table, providing scientists with a way to measure past sea levels. The findings were published today in the journal Scientific Reports. The team aimed to document the position and timing of sea levels during key time intervals over the past 6.5 million years, for which global mean sea level estimates have been highly uncertain. The project expanded on research published last year in the journal Nature, by investigating samples that are either older or younger than the relatively warm Pliocene epoch, 5.3 million to 2.58 million years ago. As part of the project, they applied numerical and statistical models to adjust for changes in the level of the land itself, including shifts caused by the waxing and waning of glaciers, and long-term uplift in the region. They then translated local sea level estimates into global mean sea level. Their results show that during key time events, such as Pliocene to Pleistocene transition, some 2.58 million years ago, global mean sea level stood at 6.4 meters above the present, whereas during the beginning and the end of the mid-Pleistocene transition, a time of repeated glaciations 1.25 million to 0.7 million years ago, sea levels were 1.1 and 5 meters lower than at present, respectively. Overall, our results support that sea level dropped significantly after the Pliocene, said the study's lead author, Ona A. Dumitru, a University of South Florida PhD alumna who is now a postdoctoral researcher at Lamont Doherty. The authors also showed that local sea level before and at the onset of the Messinian salinity crisis, a time 5.96 million to 5.33 million years ago, during which the Mediterranean largely dried up, was approximately 33 meters above present level. These estimates may offer starting points for assessing whether sea level drops in the western Mediterranean happen gradually or rapidly, the researchers said. These results therefore contribute to efforts of studying past warm periods to gain insight into the magnitude and frequency of sea level rise, the researchers wrote. Dumitru was joined in the research by Lamont Doherty geodynamicist Jacqueline Osterman, Victor J. Apoliak and Yemaine Asmram of the University of New Mexico, Joan J. Afornos, Joaquin Guinness and Angel Guinness of Universitat de les Illes Balears in Mallorca, Spain, and Bogdan P. Onak of the University of South Florida. The research was funded by the U.S. National Science Foundation and the Spanish State Research Agency.